The mean U.S. daily internet use at home is 2 hours and 20 minutes, or 140 minutes. A sample of 64 homes in Mount Erie showed a mean usage of 2 hours and 32 minutes, or 152 minutes, with a standard deviation of 80 minutes. We are interested in determining whether or not the mean usage in Mount Erie is significantly more than the U.S. mean. Run a test using a 0.05 level of significance. The population that we are studying here are homes in Mount Erie. What we're trying to measure is the population mean internet usage in Mount Erie. We're trying to show that that mean is greater than the U.S. mean of 140 minutes. We don't have the actual population mean for Mount Erie, but we have an estimate of it. We have a sample of 64 homes, and the average internet usage in those 64 homes is 152 minutes. That's a sample average, and it's an estimate of mu. It's also greater than the U.S. Mean internet usage of 140 minutes, so there's some evidence that the mean internet usage in Mount Erie is greater than the U.S. mean. But again, it's just an estimate. It's based on a sample. It doesn't yet prove anything. So that's why we want to run a test here. And what we're trying to show with our sample average there of 152 is that the population mean internet usage in Mount Erie is greater than 140. The null hypothesis will be mu less than or equal to 140. So we're going to try to reject that. Now, again, we can say in the null hypothesis that mu is equal to 140, because certainly if we can show that mu is greater than 140, we're proving that it's not less than 140. So this works well with thinking about our sampling distribution. We're assuming the null hypothesis is true, so the center then of the sampling distribution would be 140. The question is that 152 minutes strong enough evidence to reject the null hypothesis at 140? How far away does the 152 minute sample average have to be from 140 to be convinced that 140 is not in the center of that distribution? How far away? We'll draw a decision line here and create a rejection region. So our rejection region would be from that line forward. And that line is determined by our level of significance. In this problem, that level of significance is 0.05. So if the null hypothesis is true, 5% of the sample averages taken from samples of size 64 will be up in this region. If we get one of them, and again, there's only a 5% chance of that happening, if we get one of them, then we would have strong evidence to say that the null hypothesis is not correct, that the center is not at 140. It's probably something greater than that. Now, my standard normal Z alpha value for this decision line would be 1.645. And again, we could get that by going to our standard normal table, looking up 0.45. We're using the 1.645 in the standard normal distribution because our sample size is large. The standard deviation of the sampling distribution would be the standard deviation. In this case, it's a sample standard deviation, but again, the sample size is large. So 80 divided by the square root of 64 would be 10. I'm going to reject h sub 0 if z is greater than or equal to 1.645. Test statistic for the 152. How far is 152 from 140 in standard deviation units? And my test statistic is 1.2. So 152 is 1.2 standard deviations to the right of 140. So I would conclude, do not reject h sub 0 since 1.2 is less than 1.645. So 152 is 1.2 standard deviations. 152 is not far enough away from 140 to give us the confidence we need to reject the null. And so we do not reject h sub 0. Now, be careful. Do not reject h sub 0 doesn't mean we're saying that h sub 0 is true. We're just saying that we didn't have enough evidence to reject it. So that would be the conclusion of the hypothesis test. Now, let's look at the p-value. The p-value is the probability of observing a value of the test statistic that is at least as contradictory to the null hypothesis as the one computed in the sample. Now, the 1.2 does shed some evidence against the null hypothesis, but again, it wasn't enough to reject the null hypothesis. The p-value is the probability of getting anything less likely than what we had with that 1.2, given that the null hypothesis is correct. To calculate it, I'm going to find the probability that z is greater than 1.2. So I'm trying to find the probability of being in this interval, and that is the area under the density function above that interval. I can see pretty clearly that the p-value is going to be greater than my level of significance, 0.05. The p-value is the probability of getting a z greater than 1.2. The level of significance is the probability of being greater than 1.645. Well, I need to go to the standard normal table and look up 1.2. Looking up 1.2, it's 1.20. I'm in the first column there, and I get 0.3849. But again, the standard normal table gives the value from the center out to the z value. But my p-value is going to be measured from the 1.2 to the right, so I'm going to take 0.5, subtract 0.3849, and get 0.1151. And as mentioned earlier, this is going to agree with our conclusion, do not reject. The p-value in this case is greater than 0.05. So the risk we'd be taking in rejecting the null hypothesis is more than the risk that we were willing to take. And therefore, we're not going to reject the null hypothesis. Do not reject. Now again, I ran this test taking two different approaches. They're really two sides to the same coin. I'm really overall trying to determine if the 152 minutes collected from the sample is strong enough evidence to show that the population mean internet usage in Mount Erie is greater than the 140. And the evidence is not strong enough. The location of the 152 is 1.2 standard deviations to the right. It's not quite far enough to reject the null hypothesis. I set a 0.05 level of significance, the probability of making a type 1 error. I wanted the probability of making a type 1 error to be small. I didn't want to reject the null and say that the mean internet usage in Mount Erie was greater than 140 and then end up being wrong about that. I wanted a small probability of that happening. I wanted a small probability of making a type 1 error. I wanted a small probability of saying that the mean internet usage in Mount Erie was greater than 140 and then being wrong. So I set alpha at 0.05. But my risk is higher than that. And I'm not willing to reject the null. I'm not willing to say that Mount Erie's mean internet usage is less than or equal to 140. I'm not willing to say that. But I don't have strong enough evidence to say it's greater. So I just say, do not reject. In a sense, this test is inconclusive. I'm not claiming anything. Again, it goes back to a courtroom. If the evidence brought in by the prosecutor is not strong enough for the jury to find a guilty verdict, then they say not guilty. They don't say innocent. Just because the prosecutor wasn't able to prove the person's guilt doesn't automatically mean he's innocent. So, to avoid type 2 error, the jury basically says not guilty. They're telling the prosecutor that your evidence is not strong enough for us to say this person's guilty. So again, there's two ways I can look at this, and both of them will agree. I could compare the test statistic to my Z alpha value and determine if the 152, based on its location from the center, the 140, is far enough, or I could compute a p-value and compare that p-value to the level of significance, and that would conclude the same thing.